Alright, welcome to another video for chemistry. In this video we're finishing up our types of redox reactions. We're finishing up with displacement reactions. And to illustrate displacement reactions, we're going to go through what's called an activity series. This is a lab that you will do in class, and I'm just going to show you an animation that goes through that lab as well. So by definition, a displacement reaction, we are displacing an atom or an ion. Okay, so an ion or an atom that is in a compound, it is replaced by an ion or an atom of another element. Okay, you are displacing something, or you can even say you're replacing something. So, you might picture a couple going into a dance, and then one of the couple chooses another partner, another dance partner. So that partner has been displaced or replaced by another, or that atom has been replaced by another. Okay, so you can kind of see how it looks when you do just a general chemical reaction. So you have A replacing B, and then B goes into an ion state, and then your A goes into a compound state. Okay, there's also something called a double displacement, where you have two compounds, and then you have as you can see there, you have the cations that are replaced. Right? So the previous, you only had one compound replaced by a stronger or more reactive atom, and then here you have two compounds that you have atoms that are replaced. So there are three types of displacement reactions: the hydrogen displacement, a hydrogen displacement reaction, metal displacement, and halogen displacement. A hydrogen displacement we'll discuss at the very end, and metal is where we'll spend the most of our time in this video. Alright, so metal displacement. What we have here is a activity series. It's not a complete series, but it's partial. You can see the elements starting from the top going down to the bottom. The ones at the top are the more reactive elements. Okay, these elements are easily oxidized. They're very reactive, or they easily give up electrons. They lose those electrons. They're oxidized. Okay, so from top to bottom, the most reactive on the top, the least reactive on the bottom. So if I choose two elements, which I'm going to, magnesium and zinc, magnesium, because just by virtue of it being above zinc, is more reactive. Okay, so magnesium is more likely to give its electrons away if it's in a neutral state than zinc is. So let's see how this actually plays out in an experiment. What you're going to see here is you're going to see zinc, a metal, solid zinc. Here, let me pause it for a second. So you just saw a zinc metal plate be put into what's called magnesium nitrate. So magnesium is, here it is, let me pause that. Magnesium is in the solution state. You notice a positive 2 charge. That means it's missing its 2 electrons. Zinc, on the other hand, is a neutral state. It's in its solid state. It has all the electrons it needs. Okay? So the question is zinc more reactive than magnesium? And based off of our chart, it is not. So zinc is not going to give up its electrons as easily as magnesium has already. Okay, so let's see if there's going to be a reaction when these atoms come into contact with each other. And as you can see, they just bounce right off. There isn't any reaction. There's a no reaction reaction, basically. And in the lab, you're going to see this. This is going to be visible in that nothing happens. Yeah, that nothing happening is actually something happening. It is telling you something. It's telling you that zinc is not as reactive, and it won't react with magnesium. So I'm going to reverse it. Now I'm going to use magnesium solid, and I'm going to put it in zinc nitrate, aqueous solution. Okay, so what that means then is that my zinc is dissolved in the solution. It is not in a solid state, it's an aqueous state. You can see here it's got a +2 charge. It needs 2 electrons. And again, the question is magnesium more reactive, or which is more reactive, zinc or magnesium? And as I can see here, magnesium is. So if magnesium is in the solid state, and since it's more reactive than zinc, it's going to cause a reaction. You're going to have a loss of electrons from zinc. So you notice that the electrons are leaving magnesium, going to zinc. So now zinc will displace magnesium. Zinc will now become the solid, and magnesium will become the aqueous state. Okay, and that's how this plays out with the reaction series. One of the ways that you'll see this reaction in real life is that you'll see bubbles. Okay, you might even have some steam, some heat that's let off, if it's an exothermic reaction. Okay, so let's take a look at another sample. Let's look at iron and nickel. Right off the bat, I can tell iron is more reactive. It's above nickel. So how does this actually play out in an experiment? So I'm going to first start off with an iron solid, and I will put it in nickel nitrate, as you can see. So again, iron is more reactive, and it's in the solid state. So it's more reactive, which means it's going to oxidize more easily. It's going to lose electrons more easily. So as you can see here, it's very likely that these electrons will be lost to nickel because iron is more reactive. And in fact, that is what happens. So now iron goes into an aqueous state and nickel becomes the solid. Okay, so now let's see what happens in the reverse. So since I know that this was a reaction, I automatically know that when I put the nickel solid into the iron nitrate, that there's not going to be a reaction. Okay, but let's just confirm that. Yep. See, the ions will collide with each other, but no reaction, since nickel is not as reactive as iron. Okay. So what I want you to do next is I want you to predict which is more reactive based off of what you see, just a visual confirmation. So at first I'm going to start off with lead. I'm going to put it in strontium nitrate. And as you can see, there is no reaction. So since there's no reaction, that tells you that lead is not very reactive. Now let's see what happens with strontium when we put it in lead nitrate. Now we have a reaction. So again, I leave it to you. Which is more reactive, lead or strontium? Based off of the fact that you had the electrons, that strontium was oxidized, it lost the electrons, and lead did not. Which is more reactive? Okay, so I hope you were guessing that strontium is. Strontium is the more reactive element, okay? As seen by our little animation here. All right, now for the next particular demonstration, I want to show you the hydrogen displacement. So what we're going to do, the animation is going to put in manganese, Mn, and nickel and copper in a solution of hydrogen, okay, hydrogen ions, and we want to see which will react. Okay, so here's copper. Now notice where copper is. Copper is at the bottom, so it's less reactive than hydrogen, so that means we're not going to have a reaction, right? Because look, copper is below hydrogen, and as you can see here, no reaction occurs. Okay? Nothing is happening. These hydrogen ions are colliding with copper, the copper solid, the copper piece of metal, but nothing's happening. Copper is not as reactive. Okay, so we'll remove copper and let's now add magnesium. Okay, I know up here it says manganese, but we actually did magnesium, Mg, not Mn. Now look at the bubbles. Okay, there is some bubbles that are forming, which means that there is a reaction occurring. There is a displacement reaction. I'm sorry, did I say manganese? I meant nickel. This is nickel, not magnesium. So there is a reaction. Okay, nickel is more reactive than hydrogen, as you can see. Nickel is more reactive. Now we're going to change it up from nickel to magnesium, which is actually up here. I have this arrow pointing at magnesium, it's magnesium. Now look how much faster that reaction is compared to nickel. And again, look at the activity series. Magnesium is much more reactive than nickel. So this reaction occurs much quicker because it's more reactive. It is oxidizing much quicker. It is more willing to give up those electrons much quicker than nickel is. And that's hydrogen displacement. And that is displacement reactions as a whole. So I hope this video helped. And like I said, you will be doing this actual animation in the lab in class. So good luck in your study.